All right, the real world scenario example I made was from comparing multiple population means. So in my example, there are three groups, and these are groups of students whose test scores were recorded. Group A had no test preparation for the test. Group B took a test preparation course, and Group C was a self-study group. And then we want to compare these groups to testing if there is a statistical significant difference between the average scores amongst the three groups. So what I did was a ANOVA test, which is testing for the analysis of the variance. So it's a one-way test because there's only one independent variable, the method of study, and we're also comparing two or more independent groups. So I made a synthetic data set here for each group, group A, B, and C. And then, so first there are some assumptions to be able to use an ANOVA test. One is the normality of the residuals, and then also we need to check for equal variance. So the first test I did was the equal variance test, and then I also did, once I get the p-value, we can check to see if we can reject the null hypothesis. Then same thing for the Shapiro-Wilk test. First we had done we had to check for the normality of the residual, so I made a model earlier in the code, and then so now we'll test that the normality of the residuals using the Shapiro-Wilk test. Again, so once we get our p-value, we can see if we reject the null hypothesis, and then after that, if we pass those, if there is equal variance and there is a normality, we can then go on to the ANOVA test, which is what we'll be using to testing if there's a significant difference in the average test scores. So I ran the code here. Levine's test, we found the p-value to be 0.89, which is greater than 0.05, so we failed to reject the null hypothesis. All groups show equal variance. And then for the Shapiro-Wilk test, we found our Shapiro-Wilk p-value to be 0.66, which is greater than 0.05. Therefore, we fail to reject the null hypothesis. Residuals are normally distributed. So now, once we have checked both of these, we can go on to the one-way ANOVA test, and we found our p-value to be very, 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 very small. And so, since it's less than the 0.05, we reject the null hypothesis. At least one group mean is significantly different than the others. And then, to visualize that, we can see that the test prep course had a much higher average score compared to the no prep group, and a little bit more than the self-study group.